Okay, here's an interesting free response question from 2011 AP Chemistry. It deals with acids and bases. Question 1. You are given 25 mils of three different 0.1 molar solutions: a strong acid, a weak base, ammonia, and a weak acid, ammonium. They each have 25 mils. The pH of the solution in beaker 1. Well, if we can get the H plus concentration, we take the negative log of H plus, that's our pH. This fully dissociates, so the concentration of HCl is 0.1 molar, as is the concentration of H plus. So the negative log of 0.1 is 1. The pH of this solution is 1. In beaker 2, this stuff is a weak base because the ammonia reacts with water to generate some hydroxide, but not too much because it has a pretty low K sub B. Write the K sub B expression. These are usually pretty much free points. All you have to do is products over reactants. There's your two products. The only way you could screw it up is by including water. You shouldn't because it's a liquid. Omit solids and liquids. And you just write it. Excellent. They now ask for the hydroxide ion concentration in beaker 2. They want you to use this and solve for that. Well, it started as 0.1, but when it dissociates, it's going to go down by a value of x. Since x will be much less than 0.1, we're going to eliminate that, make that assumption. Therefore, the bottom number is 0.1. These each also go up by a value of x since it's a 1-to-1 mole ratio. So we have this Kb, 1.8 times 10 to the minus fifth equals x squared over 0.1. Solve for x and you have your hydroxide ion concentration. And there it is, 1.3 times 10 to the minus 3 molar. Beaker 3 is an acid. Beaker 3 is an acid because ammonium dissociates a little bit to give ammonia plus H plus, which is an acid. But it doesn't do so much. Hey, wait, they didn't give us the Ka. Well, it was talking about ammonia either generating base or acid, so we have a Ka, Kb situation. And they always multiply through to 10 to the minus 14th, so we'll just take our Kb that they gave us above and take 10 to the minus 14th and divide it by that, and the rest is your Ka. I hope that made sense. Ka times Kb equals 10 to the minus 14th, and you know the Kb. So the Ka of this weak acid is 5.6 times 10 to the minus 10th. They take the beaker 2, which if I recall is your ammonia, and they pour it into the ammonium, and they mix it, and they assume the volumes are additive, and they want you to know the pH of the solution. Well, we had the Ka expression, right? It's equal to the Ka is equal to, oh, I don't know what it was. Let's show it here. It's equal to the ammonia times the H3O plus times the NH4 plus. But since it's the same amounts, they're equal, which is cute, right? We don't know what they are, but if they're equal, we don't need to know what they are. That's equal, so that over that equals 1. Therefore, the Ka is the H plus concentration. I think that's really nice. They didn't ask for that, though. They asked for the pH. So we do have the H plus. The negative log of the H plus is the pH, and the pH is 9.25. Which makes sense because it's ammonia, the weak base. Now they're going to take beaker 1, which is hydrochloric acid, and pour it into this ammonia-ammonium mixture, 1-to-1 mixture, and they stir it. Is it an effective buffer? Well, if you haven't had the buffer unit yet, don't do it. But if you have, you should know that you did have a nice buffer, a weak base and its conjugate acid, nice. But if you pour in HCl, it's going to totally wreck it because it's a strong acid and will react with all the ammonia. And here's how they describe it. It's not an effective buffer. All the ammonia in the solution will form ammonium because it's reacting with a strong acid, so you no longer have the conjugate acid-base pair. Okay, so that's that question. And finally, they want the final ammonium ion concentration in that resulting solution, which has all three beakers mixed. Oh my God. Well, why don't we just figure out how many moles of each are present? We'll have some ammonia, we'll have some ammonium, and we'll have some other ammonium that was present in beaker 3, right? So that's what they'll do. They'll add up the total amount of ammonium, and then they'll divide it by the total liters of the solution. So originally you had H3O plus, and that'll make all turn into ammonium. So you have 0.025 moles of ammonium when these two react. You also had 0.025 moles of ammonium in solution 3, so that's 0.005 moles of ammonium and 75 mils, that's 0.075 liters. There's your final calculation. The concentration of ammonium when you mix everything together is 0.0667 molar. That was a tough question, and that was the 2010 free response question.